It's okay. Okay.
All right, the recording has started. Yeah, you can take it away, Piotr.
Okay, good. Thank you. Thank you, Wim. So for your knowledge, I'm Piotr Matysiak from Orange Innovation Poland. Why I'm here? Because we make some deep dive in the Nephio demo from one summit, where we try to make some improvements, and we propose to present what we did. So you agreed? That's why we are here. So for today's demo, I don't see the chat and nor the hands. So if you have any questions during the presentation, try to interrupt and just ask. So if you can go forward. To be on the same page, I prepared the demo setup to understand what we are trying to achieve and what end-to-end demo means for us. So at the start, we used only the kept 35DC UPF package, and the rest was deployed using the Helm charts. We did some improvements. So right now we have the kept packages for everything, but only for the package 35DC UPF, the configuration is done by the Nephio. So we didn't target to improve the specialization phase, or we didn't try to improve the 35GC operator. So what we do, we deploy the UPF. The UPF is configured via Nephio, and then we can manually adjust other packages, UERANSIM kept and 35GC kept, and use Nephio to deploy them. So end-to-end for us means, and it's common in the 35GC community, that we can access the UE, the simulator, and we can make the ping to the data network, which is internet in our case, through the PDU session. So the UE sim tune represents the interface of the PDU session, and 6 we have PDU session anchor. So this is what we achieved. We are able to configure with minimal effort the demo you provided on the one summit workshop and make it working. From the Nephio perspective, what we need to do, we can copy to the catalog alongside with the 35GC operator, also the prepared by us 35GC kept and UERANSIM kept. And then we provide with the demo on the edge one. So we create the draft package revisions on the edge one for all the packages, AgLayer UPF, of course, the 35GC operator, and other network functions and UERANSIM. So first of all, we deploy the operator. Then we can deploy the UPF Deployment CR, which is configured by Nephio. And based on the configuration we receive, we can adjust other and deploy 35GC, register UERANSIM, register the UE through the web UI of the 35GC, and then deploy the UERANSIM. And again,
Piotr, it's Wim. Maybe a question. So you created packages, kept packages for each of the additional components that you needed on it, right? That's correct, right?
Okay. I just made the one package for, and I mean, as you can see here, this is the kept package for me. So it is done based on the Helm charts. So in this kept package, you have all of these functions. And the second one is
but the kept package. So the kept package is a Helm chart basically that you deploy, right? And this, so you have 3 packages basically, UPF, and then you have 2 additional packages. One is 35GC, and the other one is UERANSIM.
Yeah, that's correct. I use the Helm to render the KRM resources, and based on the and I could modify the KRM resource itself.
So you render Helm, and that's the output of the Helm is actually put into the kept package. Is that correct?
Yeah, I improved somehow with the readability, but yeah.
Yeah. Okay.
Okay,
Thanks.
so moving forward to the
By the way, there is more people raising their hand. Sorry, I will try to moderate.
Yeah.
I think, I don't know the order, Vish and Bala.
Vish is first, yeah.
Yeah. Quick question. Your demo setup, is it still on a VM with kind clusters, or is it something different than what was in the workshop?
We tried to proceed with the minimal effort, so we took the kind clusters.
Okay, and inside of a VM, right?
Yeah.
Okay, cool.
So,
That's what to...
Cool.
The second question.
Thanks, Vish. I think I wanted to ask, I think Wim asked the question. So I wanted to ask, what is in the KPT package? So basically it is not the Helm, just to understand, just to reiterate what Wim said. So what is in the KEP package in the free 5GC packages? It's not the Helm charts themselves, but their output, right? The render.
As you can see here, we have the KEP package, and for each network functions folder, for example, in the AMF folder, we have KRM resources for config map, deployment service, and network attachment definitions.
Okay.
So this is the structure. So it's Helm charts rendered to the KRM resources.
Okay, awesome. Great. So did you also share that to GitHub? Sorry, I joined a few minutes late. Did you also share that GitHub link?
It's on the GitHub, yeah, but didn't share yet the link.
Okay.
I think Steven shared the link somewhere on the Helm chart, but I don't know where. I need to dig it up. I will dig it up. Otherwise, we'll ask Piotr for it again. But I think Steven somewhere shared it.
Yeah. It was shared on the GitHub Orange, but I think this GitHub is a personal one from you, Piotr, I think.
Yeah, I will provide the resources at the end, which I used, both the kept packages and the reference to the Helm charts.
Okay, thank you so much. Really appreciate it. Yeah.
Yeah, no problem.
Yeah, go ahead, Ravi, please.
Is it, can I ask? I'm sorry, I'm driving.
Yeah, of course, try to interrupt. I don't see the hands.
Sure, yeah. So I just said, so did you say there's an automated way to go from Helm to kept, or was it, I think today it's all manually done, right?
I mean, the Helm, you can render the Helm to the KRM resources, so you can do it. I don't know how it works for the Helm charts, which rely on other current Helm charts, etc., etc. So yeah. Here I use the 3.5GC Helm charts are not that hard to even manually do it.
Yeah.
If you consider some.
Yeah. The other question I had.
Ravi,
one second.
Sorry. No, Ravi, what I think my understanding is you render Helm to KRM, and then they probably manipulated a little bit the output, and that they put into a package. So it's a bit of, you could say there's a bit of manual operation. Is that fair to say, Piotr?
Yeah, I mean, we could provide as it is. The output we could provide just for the kept package, but I manipulated because of the readability, just for the readability reasons.
Okay. Another quick question is another quick question is that in this topology, right? How complex topologies can you do, like multiple UVs to a single G node B or multiple G node Bs to a UPF? Can you create all these kind of topologies with free 5GC today, or is it just this one what you show?
I mean, for my testing with Nephio, we tested multiple UPFs, multiple and maybe not multiple UEs. We only had just one UE, but we had multiple G node Bs. We used the uplink classifier mode, etc. But for this demo, we stick to what you provided. So just one UPF, just one G node B, and just one UE.
Okay. But is there something that automates these creations, or is it like you have to do it all manually? Like you have to bring multiple instances of the UERANSIM or something like that, or can UERANSIM can be configured to say that I need 5 G node Bs with like say 5 UEs or something like that? Is that?
It's I don't know of any automation you need to configure.
Okay, no problem. Yeah, just trying to understand. Thanks.
Yeah.
By the way, Piotr, there is another question from Aravind, but he cannot join. He asked, what is the role of the free5gc operator? If the CAP package already contains the required KRMs to deploy NFs, is UPF deployment CR used in this flow?
Yeah, so to answer it, as I mentioned here, the UPF configuration is done by Nephio. So in fact, the UPF deployment CR configuration is done by Nephio. So we deploy the free5g operator almost as it was on the One Summit workshop with minor changes. This creates the UPF, and we didn't extend the free5gc operator. That's why for other network functions, we have the KRM resources. As I understand, the addition of the IMF,
yeah, I think it's
R1 goal, right?
I think it clarifies. I think he's probably cannot talk. So, but I hope it clarifies the question. Maybe I phrase it in how I understand it is that UPF deployment is done through Nephio as with the One Summit. So as a result, we use the full iteration. Okay, yeah, and then the rest is done via a different mechanism because we didn't do anything there. Yeah, okay. It seems that Aravind is happy with the answer. Thanks.
Okay, good. And if you will have any question afterwards, try to reach me. I can answer later. Right?
Yeah. Yeah.
Okay, can we move on?
Yes, move on. I think we are through. Sorry.
Okay, so maybe this clarifies. So assume that we proceed with the One Summit workshop and we deploy the free5gc operator and we deploy the UPF deployment as it is. The pod is running, but in fact, it's not functional, at least in my environment. We have two issues. First one is related to iptables, permission denied, even though we are root in the container. And the second one is related to GTP 5G module. So those issues need to be addressed. And for the issue one, the solution we did is to add the security context to the free5gc operator. So in fact, we a bit modified the logic of the free5gc operator. Is the only change that we added the security context to contain the net admin capabilities in the way that we can configure the iptables later in the container. Right? This is maybe not required in such form, but we need to somehow include this security context. So from now, I will use my own image of the free5gc operator with this logic included. So this one is added to the deployment of the UPF. For this issue 2, I don't know if it's issue. We need to install.
Actually, sorry.
Yeah.
Going back. Sorry, going back to the security thing. So I got the stuff from the Helm charts that you guys did, and then obviously it works for Helm. So is there anything really different?
I don't think I understood the question.
Yeah, so the free5gc operators, their logic is actually based on the towards 5gc Helm charts that Orange actually produced and open sourced.
Yes.
And then over there, if I do a Helm and store, obviously there's no need to do this. I just
because
wonder.
It's included. It's included in the. This is included in the Helm charts, but it's not included in the operator.
Okay. Oh, okay. So
you had to miss the.
I see. I probably missed it then. Yeah, I was I was wondering. Someone. So Helm obviously works. I tried that too. But then when I wrote an operator that didn't work, I thought it was some other external security context that you have to put in. But yeah, that's good. Thank you.
Yeah, so as I said, we need to install GTP 5G module. It's not required for all the core open source cores, but for free5gc, it's required. I tested multiple versions. In fact, not all versions of GTP 5G module is compatible with the kernel, which is provided in the VM, Google VM, which is as default in the OneSummit repository in the Terraform. So I recommend using the newest one because it's work well. So easy fix, we need to install GTP 5G module before we instantiate the UPF pod on the worker node, that it can use it and create resources. So after we resolve these issues, we could try again to deploy UPF deployment CR, but there is another issue. Next hop has invalid gateway. And from here we can discuss, I think. I don't say that the solution we provided is the only one legit solution, but I think it's the N6, network attachment definition is configuration. And issue 3 for me is composed of two things. First of all, if you consider Docker networks, in the OneSummit repository, there are two ways to create the Docker network. First of all, is using pure Ansible playbooks. And due to the environment, it's not working for me. So I use the second option with the script, which is provided also in the repository, official repository. They differ in a way that the kind subnet is in different range. I mean, for the Ansible, we have 172.18.0.0 with max 16, and here we have 0.80. In fact, I don't know why you provided 172.0.0.1 for the IP prefix of N6 interface. With my knowledge, I don't say it's only good one, but for me, it should supposed to be consistent with the kind network. And this is what I will do.
I agree, Piotr. I agree. So this is just, we did not have time to look at this, but I do agree with you. I think I gave 172 because nobody told me anything. So I just created it. So, but I do agree with you that this should be lined up.
The allocations of the network at the IPAM side doesn't really match the reality of the Ansible at this point. So there's something we definitely will fix for our one. Absolutely.
Yeah. So this is the first point, and the second point for me is the cluster context. I can see in the Ansible that you create this Ethernet 1 interface for each machine, for each container, which represents a Kubernetes cluster. But again, this need to be consistent with the Docker network for me. So what I did, I used Ethernet 0 as a master interface, at least for N6, and cluster context definition allows us to provide only one master interface for entire cluster. So I use Ethernet 0 for all network functions.
And is that so? That's a bit of a discussion, I think, because this doesn't represent the reality in my view. So in the sense that normally when you do the data plane, you actually put it on a dedicated interface, not sharing with the Kubernetes network, right? So that's why we have Ethernet 1 there.
Okay, I can understand that. From my perspective, I've tried to use the MAC-VLAN interfaces, and when we try to reach the internet, maybe we can, that's why I said we can discuss, because maybe there is other solution. But
we'll have to discuss this. But what is true is in the Ansible playbooks that we had for the OneSummit, there is a PR open that fixes that, is that the router attached to the cluster was not configured, so it would never come up. But I was stuck with the first with your permission thing, so we never fixed it. But I can try the other way around. If with this fix, we can try it and see what happens. But we have to do. My idea was always for anything that is related to secondary interfaces, if you will, right, which we configure through network attachment definition. they should always go via dedicated NIC. And that's why we injected Ethernet 1 into it, because that's representative more to the real world.
So just to piggyback on what Wim is saying, I mean, ideally in Nephio, I'm not talking about this specific example, this should all be configurable, right? Ideally, all the data plane stuff should not be on the, as a best practice on the Kubernetes management plane. So you would have all the 4 interfaces, maybe with their own Multis interface. But again, should be configurable at the end of the day per solution, right? But I think this is fine. This will definitely work for now.
Yeah, I agree.
So all 3 of the secondary interface on UPF maps to ETH1. I don't think we're not changing the ETH1 address, but then we have to bind it to at least the secondary interface, right?
Yes, so that we do, but what you see in the One Summit at the moment, because we were stuck in UPF deployment in November, I think even after the workshop, I proceeded a little bit, but I was stuck. And as such, we didn't go to the whole flow, but I already saw, because in, I think, January or February, I created a new PR on the Ansible playbook. I don't think it's merged yet, where I saw that a bunch of configuration was not consistent. So,
so in other words, Summit, only Summit, we didn't even have your container B route, your container lab router.
To Tal's point, it is configurable, but we didn't configure it consistently at the moment. So it's something we have to fix. And I think Piotr moved it to ETH0. I prefer to move it, to keep it on Ethernet 1 and make it consistent on Ethernet 1, because then we represent more the real world. But let's see. Yeah, we have to figure out what to do.
Yeah, I agree. Even if towards 5GS Helm charts, there are just 2 interfaces for the configuration. I didn't want to go deep dive into Ethernet 1. But as you all said, we need to reach the gateway, but it doesn't matter on which interface. So for the sake of the demo and the simplicity, I modified to the Ethernet 1 for all the clusters. And also I modified the IPAM prefix for N6 to match the kind network, which is consistent with Ethernet 0 and at this point. Okay, so we could try to again deploy the UPF deployment CR, but I think you are aware about this. The IPAM is not aware that we already allocated some IPs. So it allocates the 0.2 here, but this is already allocated for one of the containers, which represents the Kubernetes clusters. That's why at this point I, for simplicity, manually changed to 0.20 for N6. Because it's not used by any component. Okay, so at this point, we can assume that we deploy the UPF deployment CR. And at first, we still got the next hop has invalid gateway, but I tried to give a chance. So I added the IP route to the gateway through the N6, and the UPF logs were looking okay. I don't think it's good because we shouldn't be obliged to modify anything in the IP route configuration, because the Helm charts works fine without this, but later on why this may happen. So we try to make
I think, Piotr, I think if we change the NAT config, this will work. So normally if you put a default gateway in the NAT config, you don't have to do that, I believe. Right, so that's my understanding.
So if we can reach the default gateway, it should be able to route. We offload the routing to the default gateway. So in that case, again, the only Summit, I don't think we would have a sophisticated router sitting as a default gateway.
So like I said, the simplest way here provided, but this is part of the discussion. We don't say this is the only solution here. Even if I
recording in progress.
Even if I change the command, I got this strange log. I mean, there is a communication with SMF from the UPF perspective, but this is first time when I saw some requests duplicated the warnings and some error. But I tried to give a chance, so I deployed the UERANSIM and tested connectivity. Of course, it didn't work. Even in SMF, there are some errors and warnings. So I didn't go deep dive why this configuration is not working well, but I found other solution based on my previous testing and my knowledge I gained from this testing. And the solution is here. I just wonder, because IPAM provides the IPs with the mask 32. For me, I don't know if it's okay in the Multus perspective. I'm not Multus expert at all. But I always use the masks which is consistent with the subnet length. In this case, for each IP length 24 masks. So what I did, I manually changed the IP allocations to 24. I saved the revision, of course, the kept functions updated, UPF deployment and the network attachment definitions. And at this stage, we didn't need to add the additional commands to tell where the routing is. My understanding is that maybe Multus, when we provide the mask 32, Multus, we say that this is the only address in the network. Maybe this is the reason. I'm not sure here. But when I provide the mask 24, it's okay. We can deploy the UPF. We can deploy other network functions, and we can see that the session setup for PFCP is done in the good way.
By the way, this is a bug in the IPAM. I think you find the bug in the IPAM. This is they should return a /24, by the way. But
yeah.
So for me,
it seems like there's something weird about host. 32. Yeah, if you're buying a host route, maybe Multus, maybe 35GC. Yeah, but it seems like
but I think the /32. Did I understand correctly, Piotr? Is that in the configuration you had a /32 and you wanted a /24, right?
Yeah, I had allocated with 32 and then manually changed to 24 for each item.
Okay.
Allocation.
Yeah, I think it's a bug. That's my. But I think I fixed it. But I think it's a bug. Yeah, from me.
Okay, good. So we're on the same page. In fact, those are the logs of the UPFs when it connects with this SMF for the first time without the UERANSIM, and it look okay. We should target for this Helmchart's version, let's say, to show such logs, to be sure that everything is fine. So we can try to deploy the UERANSIM. Of course, the session is created with the IP allocate from IP pools allocated also by the IPAM. We get new logs on the UPF side. So session establishment and session modification. So UPF is adjusted by the SMF to make the routing in the right way. And when we check the ping, which was the goal of this demo, we can see that from the UE, we can send the ping through the UESIM tool, which represents the PDU session, to the Google.com. Of course, on the UPF side, I made the TCP dump on the PDU session anchor, which is N6, and it's working. So that was a goal. That was few issues which needed to be resolved. And I have a few slides about the specificities of the configuration of other network functions, but if you have some question related to the first part, just you can ask right now, or we can move on.
I have a question about all the architecture presented in the first slide, because I'm not familiar with Nephio. It's my first time hearing about it. I mean, I joined this meeting to learn more about it. So you are using Nephio to do configurations. And which type of configuration? Is it day 2, meaning telecom configuration, or?
In fact, the configuration from the Nephio perspective is the same as is on the one summit. So we only configure the CR of the UPF deployment.
Maybe I answer. So it's not day 2 configuration. I don't know who asked the question exactly, but it's basically more the configuration related to the infra deployment of the network function. So we give it IP address, we give it network connectivity. So the configuration of the NF itself is actually not done through Nephio at the moment. So it's a config map that is rather static, but it's not manipulated by Nephio at the moment. But really,
it should be able to do it if you change anything. But then, yeah, I mean, we'll have to test that. But if you change any IP address and things, then it should be reflected too. But then we haven't actually done the whole work. But basically, you have to kill the pod, change the config map, and then spin the pod back up. We haven't done that on the operators. So that's a day two. That's a day two thing.
There is an operator, a third-party operator that can do that automatically. So
okay.
It's called reloader.
Yes, so we have operators to create the Kubernetes resources. So that's what we call a day zero configuration. Then we'll have Nephio to do all the overlying infrastructure that the pods or the Kubernetes resources need to communicate and the security check, etc. That's what I understand.
Yeah.
Okay, thank you.
So are there any questions or we can move on?
So one question. So if I understand with what you have accomplished till now, so I mean, you have the entire free 5GC kind of, I mean, the different network functions as kept packages, and you should be able to kind of propose it as a draft into Porch, and then it gets pushed into, you know, any of the repos, and config sync comes up, and then you should be able to get the end-to-end UE to internet connectivity through the GNode, right? That's what you accomplished.
Yeah, that's right.
Okay.
I mean, so Nephio only spin up the UPF in this case. So SMF and everything else is still, you're still using Helm, I guess, right?
Yeah, I think just bypass it. That's what I understand.
I see.
That's
great though.
No,
yeah.
Not exactly,
so
Stephen. If I can.
Stephen, so maybe can I quickly say, I think they used the kept side of Nephio to do the installation, but the kept file is rendered through Helm. So they use the kept part and ports to do the installation, but the package is created from a Helm chart. It's rendered from a Helm chart with some minor modifications, right?
Okay.
So but they use
so you folks actually build kept packages off of the Helm charts.
Yes.
Wow, okay.
Yes.
Interesting.
Yes.
Wow, thank you. That's actually very comprehensive.
And I think
Wim, please finish your thoughts. You're saying something. Wim, please finish your thoughts.
Yes, I just wanted to, so I need to do the moderator a bit, but yeah, so I think I'm done. I just wanted to clarify what Nephio means to certain people. It's different things to certain people. What we did not do for other than the UPF is going through the whole, let's say from the beginning with the specialization and do the modifications and da. Here it's basically Helm chart rendered to kept package and then installed via kept and config sync, right? But the UPF was basically hydrated, if you will. The rest was kind of Helm towards kept. That was my only clarification I wanted to.
I see. Okay.
And some people also say that it's Nephio, but just to
sort of.
Nephio,
this is like a complete shift left. So SMF and AMF complete shift left model. So it's still Nephio, quote unquote. Yeah, sure.
Yes, correct. So depends on who. Yeah, for certain people, Nephio it means different things to different people. That's why I wanted to clarify. Sorry, I don't know who is in line.
Bala's next, I guess.
Yeah. Thanks. So it's in line with what Wim, you and Stephen are discussing. So for the, I think I understand this, but just wanted to clarify my thoughts are right. So UPF is going through our pipeline. Basically, it will go through the proposed publish life cycle, and then we will be setting up the IP addresses, connection, etc. For the SMF, for example, the IP addresses are they directly taken when the Helm charts are rendered into their corresponding KRM artifacts such as services, deployments, etc. The IP address for the SMF requirements are they directly taken from the values file, and that's what gets propagated all the way through to the workload cluster, or any changes done there? That's what I wanted to ask, because for the UPF, I understand it goes through our hydration process.
Yeah, so I think we can modify at different levels. What I will show, I don't want to mix, but I will show the value files of Helm charts where I modified the files, but you can also use the Nephio web UI to modify the packages. Maybe it's not a good option because you need to go through all the resources and provide the good IP addresses, but you can do both. You can modify on the Helm chart level and then render, or you can take the kept package I provided and manually adjust the network attachment definitions, manually adjust the deployment, etc.
Got it. Yeah. Thank you so much. So which option did you choose actually?
So I started from the Helm charts before I even created the kept file. So I modified the values. And for the basic scenario when we have only edge one, it's working well. But right now, if I would like to deploy for the edge two, I will get different IP addresses. So I would need to also make changes in the other network functions. In fact, only in the SMF. But you know, you need to adjust. We didn't provide any logic to make it.
Got it.
To make packet specialization automatic. So you got the output from the UPF, what you got from the Nephio, and you need to adjust at any level.
Got it. Good. Thank you so much. Really appreciate it. Yeah, that clarifies. Thank you.
Yeah, I think I'm next. The question I had is the security context that you said that you added. What was the name of the file that you added the security context?
It's the logic in the 35G operator to, in fact, it's template for the deployment. For the deployment in the UPF deployment operator. Not for the UPF deployment.
Yeah, it's actually inside. It's actually inside the code itself. So
inside the code itself.
The operator code itself actually builds the entire deployment. They're very opinionated based on based on Orange's guys' Helm charts.
Okay. The reason I was asking was that because there are some deployments for sure where you need to provide these privileges. Should it be kept in the code or should it be kept in the actual definition of the template? I was only trying to get to see if there is a discussion that can happen later. So that's why I was asking.
Yeah. So yeah, we should have that discussion later. I mean, it's not written that way right now, but yeah.
Okay, so it is currently in the code, inside of the code.
It's inside basically. The code, yeah.
Okay, thank you, Stephen. That's it.
Dimitrio?
Just a quick question to be sure that I understood how this Helm thing worked. So you actually run a Helm dry run on your current Helm packages, and then this created all the YAML files that are hydrated with the values, and then you took that and put it in a KBT package. Is that what you did?
I don't know why, because I don't remember. I think it's the Helm has render command. I'm not 100% sure, but you can provide the command to render from Helm to the KRM resources. So I didn't do dry run and copied the files manually. I had the files already in the directory.
But this is more or less, I mean, you had all the Helm YAML files, and then you took that and put it in a KPT package.
Yes. That's what I did.
Okay.
I would imagine it's a render manifest. There's no direct translation from Helm charts to cap packages yet. So they would have to render the whole thing into resolve manifest and then build it inside as resources. And then maybe like readjust the values as you go through using UI or something. So
yeah, just like you said, I rendered and then initialize the new kept package.
Okay, thanks.
So is there anyone in the queue for the question?
Yeah, that's it. Go ahead. Thank you.
Okay, so it will be quick. And as I say, this is provided on the Helm chart values, but we can modify in the kept itself, in the kept package. So in the free 5GC operator, you use the version 3.1.1. So I stick to that. So for other network function, I use the same version to be compatible. So here we consider that we keep the default configuration for PLMN, SNSI, DNN, etc. So we do not care about these specificities. Also, we leave the default configuration for communication via SBI, and it's using cluster IPs. So we assume that all the network functions except UPF are in the same cluster, in the same namespace. So we will focus to just N2, N3, N4, and N6 reference points of the network functions. In fact, most of them do not have such specialties. So we can keep those listed network functions as they are without any changes. So we will proceed with IMF and SMF because the configuration of those two is imposed by the Nephio injectors for the configuration of UPF, which is done in the specialization phase, if you want to say. So on the IMF part, as you may know, we have N2 interface, which communicates with the Gnode B. And on the UPF side, we do not consider N2. So here in the IMF, we can stay with default. We could change, but we stay with the default configuration on F2 because it's not imposed by the Nephio itself. It's not related to the UPF. The point which need to be noticed here, I provide Ethernet 0 as the master interface, as I discussed previously. And if you would like to use Ethernet 1, we need to provide here Ethernet 1. So in fact, the most configuration is done in the SMF. So first of all, we look at the N4 IP prefix. We provide, which is provided for the IPAM, and we provide the same configuration for the SMF. So we provide the right gateway, we provide the subnet, and we manually took some IP address from this range, which is not used. So this is N4 on this SMF side. So when we provide such thing, and it corresponds to the N4 on the UPF side. So there may be connectivity defined in the modus.
Yeah.
The second thing,
Piotr, maybe one quick question. Do you care whether the SMF is because normally there's multiple UPFs connecting to a single SMF. So the idea that we have to fix this is that the UPF will know the IP of the SMF, and then that's how we render the configuration of the UPF. Is that something? So in other words, is that the order? Does it matter? Do we need to give the UPF to the SMF, or can we just rely on UPF just knowing the IP from the SMF, and the SMF doesn't need to know the IPs of the UPF?
In the free 5GC, it must be defined in the SMF configuration, which will be showed later. So each UPF in the free 5GC need to be registered in the SMF configuration. In fact, I know.
Okay, so you have to. Okay, so.
Go on.
Yeah, I know in Nokia it's not like that. I know for us we don't have to have that dependency, but okay, it's really bi-directional binding.
UPF is not aware about SMF. Only SMF is aware about the UPF, and I know that not for all open source projects it's the case. I think probably the NRF is used.
Yeah, we had that. Wim and I had that conversation a couple of days ago.
Yeah, I just wanted to.
It is a pretty messy configurations for that matter, but we also have to manage dependencies. In that case,
I just wanted to understand. So what you're saying is actually the SMF needs to know everything. So that means that the SMF will be dependent on the UPF. And I was hoping it will be the reverse, but it seems to be not the case. Yeah. Okay, no worries.
Yeah, it's specificities for the free 5GC itself, not for the core as 5G core.
Yeah. By the way, Sagar has raised his hand. Sorry. Yeah.
Yeah, but just adding on what you said, Wim. Actually, I think it just depends, because it's for PSCP session. So
Yes.
for PSCP session, you can. I mean, both of them can do it via 3GPP. So I think I'm not pretty sure if 5GC supports that. If UPF starts the session or SMF, but if there is an RF, then it can go via an RF directly, and then we don't really need the configuration. But then it really depends if in free 5GC we can do that or not. If then we don't really need to mention.
Yeah. It seems here for free 5GC, what I understood is that the SMF needs to know all the UPFs it connects to. So that means that he needs to have all the information. The UPF doesn't care, it seems. So it means that the SMF calls to the UPF, it seems.
Yeah, I wouldn't put my heads on the stake, but I'm almost sure in the 3.5GC implementation is the SMF who discovers the UPF, and the other way I think is not deployed, is not coded, nor the registration via NRF.
But Piotr, it's not really discovered. It has to be configured. Is what I understand, right? So
explicitly configured.
It's not really discovered. It's really configured.
Yeah.
Okay.
Okay.
We have one more hand up, actually.
Yeah, sorry. Yes,
that's Wim. That was actually Wim.
Actually,
no,
it's actually not Wim. This is Paul from Google.
Oh, I see.
This is Paul from Google. Sorry, my name isn't appearing. Just a quick note that it could be discovered if there's a controller that manages it, a provider, but I don't want to get into this right now. We have 10 minutes left. I mean, we can continue going into the details, but I want to maybe discuss the next steps with this. First of all, I want to say this is really moves us forward. This is way beyond what we have right now. I want to know if Orange is interested in contributing this code to Nephio so we could evolve this for release 1.
It's the tough questions. I mean, I'm not the one who makes the decision.
Yeah, maybe we need to discuss internally, but obviously, yes, I think we are willing to share what has been done. But now the question mark is how we can contribute to the end-to-end task and so on. That's something we should discuss internally.
But for me, I would like to go through because these are all things that we have to cover for our one.
Yeah, I know that. Yes, that's right.
And who does it for me? Okay, we'll sort it out. But for me,
yeah,
I would like to understand what is happening here because we need to figure out how to do this. And so far, this information has not been. I discovered some of this on Tuesday, by the way.
Yeah, and then for R1, we are moving SMF and AMF. I mean, the goal is to move in SMF into more operator model also. So it'd be nice to know what the configurations are needed.
Okay, I do understand that. So perhaps the product of this work could be not code, but a design document that basically summarize all of this in depth in terms of what we should be doing in Nephio. Does that make sense?
Yeah, I mean, for me, they are sharing right now what they found, right? And then we can take it from there. So let them finish first what they have found, and then we can see how we go from there, right?
I think I'm here a little experienced with 3.5GC, so I don't think there will be any problems to share the knowledge with you guys if there will be need for that. But as Eric said, we probably need to discuss about more complex contribution. But if you say about knowledge, that's why we are sharing because.
I think I think that's the first key is really to share what has been done by Piotr on the team.
Yes.
And obviously, yes, that's something you can rely on. Maybe I think some key point has been identified that maybe to be corrected for R1 and to be sure that we can deploy at the end of the day 5G core that is running fine, because I think it's also important to demonstrate that. Otherwise, I think we will miss some part of the demonstration. So now the question mark is how we can contribute within Orange to progress together. Yes, we need to discuss internally, but definitely we can. Yes, what has been done will be shared, obviously.
Okay, thank you.
Thank you.
I vote for moving forward with the discussion and take the contribution question discussion offline to another session, because I rather see how this is done than spend more time discussing how Orange can.
The discussion is over. We're moving ahead.
Okay, cool.
Okay, so we try to make it in 8 minutes. So as I said at the beginning, we do not care about the specificities. So the SNSI, DNN, etc., we can leave it as it is. Other components are, for example, IMF is configured in the same way, so we can skip that. The most important part is the user plane information, where we define user plane nodes. Here we can define more than one gnode B, for example. Here you can see only one gnode B, and you can see only one UPF. And this UPF configuration need to relate to the configuration which is provided by the Nephio. So this is the N4 allocated by Nephio, IPAM. This one is from the pool allocated also by the Nephio. For the it is the address the pool for the IPs.
Right.
And we also got the N3, which also need to be consistent with the UPF configuration to be quick. And if you'd like to extend that, we need to define, first of all, in the 3.5GC, we can have different UPFs, because you do not consider yet, for example, the N9 interface, right? So we could have, let's say, intermediate UPFs and anchor UPFs, and they are configured not in the same way. I mean, because for example, in the intermediate, we need to provide, if we have intermediate UPFs, we need to provide also the N9 interfaces, and we do not need to provide N6 for the intermediate UPFs.
SMF even care about N9? Wow.
Yeah. It's limited. It's limited, but we can define two PD, at least one default and one specific PDU anchor for the uplink classifier mode. So yeah, there is also.
But Piotr, so what you're saying is actually the SMF cannot be deployed unless you know the UPF. What if you have 10 UPFs or you don't know how many UPFs can you add? So can you add this thing on the fly, or can it be only be
based
configured?
On my knowledge, it's everything static. You need to define the configuration, then you need to run SMF.
Yeah, the only config interface that 3.5GC has is a file, so you have to load the files and reload the pod.
Yeah, I have a way to solve this, but we shouldn't go into detail. But even with what we have in R1, I know how to solve it. I have a way to solve this. I think. Yeah.
Okay. So if you
maybe I can
maybe
I can complete the response to this question based on my experience with 3.5GC. So first of all, I'm Kishan Abdaro from Orange, and I'm working on the HAND project to deploy 3.5GC and test with UERANSIM. And for the question of interactions between the SMF and the UPF, so I think it depends on the project used to deploy the 5G core, because in the 3GPP we have multiple possibilities. We have several possibilities. So we have the possibilities to specify, for example, the address of the SMF in the UPF. So we can do it bidirectionally. But in 3.5GC, we have to do that in SMF configuration. So I think, but yeah, in order to make it dynamic, I think it's useful to have an operator that discovers all UPFs and add the new UPFs in the SMF configuration and restart the SMF each time UPF is added.
Yeah, I mean that would be what is needed to be done. Yes.
Yeah.
There is another. I think there's another idea here. Or at least my idea is different. So we don't have to restart. We just wait till the SMF. we know how many UPFs there are. So we put a set of CRs in the SMF package, and they will not hydrate unless they are resolved. So it's very easy to do. And the IPAM has the knowledge to do it today. So it's just a matter of putting the right CRs in the right place. And we can do during specialization.
We can delay the SMF package by being approved until all the UPF are being pushed down. Yes.
So correct. That was my related question, but we cannot do all the time. Right? There could be a day 2 operation for the SMF. We may want to start. We may
for R1, I'm talking about. So I don't like. But for me, this is a limitation of 3.5GC the way it operates, right? So we should not do the design necessarily for everything of 3.5GC because it's very restrictive on how it operates. But we should at least. If we can show that we can do it, it's already a good thing. But I don't think it's the right architecture to promote. But we have to have some mechanism in place to resolve this interdependency, and I think we have the mechanism to do so for R1. But it's not it will not be changeable. I mean, when you change it, the whole thing will have to be restarted. I agree with that, but I don't want to have per UPF that comes up a restart of SMF. That I think is a bit too weird. But I think
day two is a completely different discussion moving forward.
So I said day 2, just to clarify. So we have one SMF and a few, say 2 UPF already, they are happy running. And the third UPF instance, we need to bring it up and then configure the SMF back. That's what I meant by day 2. Anyway,
that will require the SMF to be rebooted. So there's no other way.
Yeah, but what I'm proposing is a bit different, Bala, is you put a set of CRs in the SMF package that are UPF dependent, and you query the IPAM to see if the IP already resolved. If so, you can continue. If not, you wait.
Yes.
So we have 1 minute left. I agree with you, Wim, but I would do everything in the workload cluster. If you have operators running, they would not create the workload until they actually coordinate the full configuration between themselves. I don't think this is.
But you cannot because.
Yeah, go ahead.
You cannot do because the UPF runs on another workload, so you cannot even do that. But okay,
sure
let's move on.
They connect to each other. They can those clusters can talk to each other.
Sure, but okay. Yeah, let's move on.
Okay. Well, we're out of time, and we do have another meeting just after this.
So are we going to request them to come back again?
Also, can you share the slides? It would be nice.
How many more slides? If it is 1 or 2, probably we can just.
How much more slides?
I would rather stay in this discussion than whatever's next.
I mean, 2 minutes maybe. It's almost over, right?
Correct. Let's finish.
We could discuss deeply. So if you have any question about the SMF configuration, just try to reach me out. So in the UERANSIM configuration, we do the same type. We can stick the N2 network as it was because we don't care right now. We adjust the N3 to be aligned with the IPs allocated by the IPAM. And then we take one of the addresses from the range and we provide the N3 for the GNode B. In the way we have communication between GNode B and the UPF. The rest can stay the same in the simple words. And remember to register the UE before you instantiate the UERANSIM, right? So you deploy the core, then you register the UE in the 3.5GC via web UI. Only then you can register the UE of the UERANSIM to make session to be created. In short word, that's all. I provided some reference here, and that's all. Thank you.
Thank you very much, Piotr. It's really appreciated. Very good. Yeah, very good.
Yeah, greatly appreciated. It's very helpful. Thank you so much.
Yeah, no problem. You can reach me anytime you want.
And right on time.
Exactly.
And this slides on the drive.
Okay.
I think
we'll share wherever. But very much appreciated.
Yeah, if you can put a link also on Slack, that would also be helpful.
Yeah,
I will do in the few minutes.
Thank you.
Thank you so
much.
Thank you
very much.
I appreciate it.
Thank you. Bye.
Have a good day. Bye.